This is the work for Wednesday, which you need to hopefully watch before the lesson period 3 on Wednesday. So this is in lieu of the lesson in the morning on Wednesday. Okay, it's about combinations. So combinations when order doesn't matter. Things like picking a team or picking a committee. Here we go, for example, how many committees of 2 can be chosen from 8 people? Now the way I want to do this for the very first 2 questions is to think about actually picking 2 people from 8. So you can pick, using the fundamental counting principle, you can choose 8 people for the first one, and then you've already chosen that, so then 7 people for the second one. So 56 different ways of choosing 2 people from 8, but you have to think about the fact that that's too big, because if you pick, person A and then person B, that's going to be the same committee if you pick person B and person A, but they're counting separately here. So because you're picking 2 people, and let's just use A and B as an example, they're counted twice and they shouldn't be. So it actually has to be divided by 2. So what do we get? 28 different ways of choosing 2 people from 8 people. By the way, this 56 is the same as using NPR, is the same as saying from 8 people. How many ways can I pick 2 people if order matters? And I'll just show you NPR. It's going to be 8 NPR 2 is 56. And then divide that by 2. Obviously there's a quicker way to get that, which we'll talk about in a minute. All right, what about 3 people from 15 people? Well, it's 15 times 14 times 13. That's to get the 3 different people in order, but because order doesn't matter, A, B, C, 3 people can be written as 3 factorial different ways. So this has got to be divided by 3 factorial. What is that? I'll just work it out. 15 times 14 times 13, which is 2,730, divided by 6, so 455. So that's the number of ways which you can pick 3 people, committees of 3 people from 15 people. Now again, you might notice that this is 15P3. So for the first one, we got this one up here was 8P2 divided by 2 factorial, it's the same thing as 2. Down here it was 15P3 divided by 3 factorial. So it does end up giving us a rule. You need to write this down actually. So the combination, NCR, is the number of ways of picking unordered selections of R objects from a total of N objects. So NCR is picking R objects unordered from N objects. And actually equals a rule, that's what this is actually becoming here. It's NPR, as we noticed on the other page, all the time divided by R factorial. Now you might remember that NPR is N factorial over N minus R factorial from yesterday and Monday. So now if I put that in here, you just end up with an R factorial on the bottom. So it actually ends up being N factorial over N minus R factorial, R factorial. So you need to know both of those things. Now of course, there is a button on your calculator which is very nice and it does it, and really most of the time we're going to use that one most of the time, but you need to know the definition of it like this, being this, permutations divided by R factorial, and this as a rule. Now just a small thing, you will see sometimes they're written like this, NCR. This is NCR, can be written as, this is called choose notation. They're just like 2 big brackets with an N and the R above each other. It's called choose notation. All right, so let's use it. This is fast if you just use the NCR button, so let's stick to that. How many committees of 5 can be chosen from 15? So that means from 15, you are choosing 5. So C sort of stands for choosing. Of course, you've got to make sure this order doesn't matter. Order doesn't matter for a committee. The 5 people are just going to be the 5 people regardless of who was picked first. So you just put that in your calculator, and I know you're pretty familiar with this. 15, NCR buttons down here, 5, 3003. Okay, next one. So we'll pick some ones with restrictions now. Things that you have to actually think about. How many committees of 3 seniors and 2 juniors can be chosen from 9 seniors and 6 juniors? Think of them as 2 committees. Just do them separately and multiply them. So how many ways can I pick? Let's just do the seniors first. How many ways can I pick 3 from 9? 9C3. Okay, juniors. How many ways can I pick 2 from 6? 6C2. So the bigger number is always at the top. Okay, now this number of committees, which by the way is 9C3, 9C3, this is 84. For each one of these 84 committees, there is a certain number of junior committees we can have. So that implies times. We want the both to happen. So it's this times that. I've already got the 84 there, so now I'll just go 6C2, and you get 1,260. All right, now let's do this one. This is about, I picked Emily and Jake as random names to use in this question. You want to pick a team of 6 men and 5 women from 10 men and 9 women. So, now let's talk about 2 particular people, Emily, one of the women, and Jake, one of the men. And they hope to be chosen in this team. So what's the probability? So suddenly we're going to have a fraction as an answer, or a decimal or percentage, that both will be chosen or neither will be chosen. The key to doing these questions is to take them out or put them in at the start. Both will be chosen. Let's put them in. Okay, so this is it. Put them both in the committee. So anyway, let's actually, before we even do that, no restrictions. Let's do no restrictions first, just like the first question. If there's no restrictions, this goes in the bottom of the fraction. In other words, how many ways can you pick from 10 men, 6 men? 10 men, 6 men, and from 9 women, how many ways can you pick? 5. So 9C5. That's no restrictions. I won't even worry about what the answer is. Okay, that's the number of committees with no restrictions. That's on the bottom of the fraction. So let's do it together now. Probability, both chosen. So 10C6 times 9C5 is on the bottom because that's the number of ways, and that's the number of committees you can pick. Now, if they're both chosen, they're both automatically in. Let's say that out of these 10 men, we're going to choose 6. Let's say that Jake is already in. So we're actually choosing 5 men from 9 men. So we have that. And what about the women? We're going to say that Emily is already in. So from 8 women, not 9, you're going to choose 4 because one person's already in there. This becomes, I think it's like 1 in 3 or something, or 3 in 10. It was a really nice answer. I did it earlier. I'll just check it. Yeah, it's 1 in 3. One third. So it's quite likely that they're going to get in. Well, it's not likely. I mean, it's more likely they're not going to both not going to be in. So there's a 1 in 3 chance that they'll both be selected, which means, by the way, there's a 2 in 3 chance that they won't both be selected. But they can't do this question that way because this is if neither of them are chosen. 2 over 3 is if one of them might be in. Okay, let's do neither will be chosen. It's almost exactly the same, but of course the numbers are different. So here you make sure they're not included. You take them out. You don't put them in, you take them out. So we still need to pick 6 but we're not choosing them from 10 because Jake's not included. We're choosing them from 9 people. So it's only the top number we change this time. And for the women, we are choosing from 8 because we're taking out Emily. We're still choosing 5. And on the bottom is still the same thing as what we had before, 10C6 times 9C5. And that is 8 over 45. So that's how we work on the questions, that have got restrictions. There's a lot of questions here, so I want you to do all the odd ones, keeping in mind that there's a lot there. So just keep churning through as best you can. But here, this thing is your magic friend, NCR button. That really does make this so much easier. Okay, good luck.